Welcome to Unit 7, Sequence Series, Lesson 4, Arithmetic Series. Learning goal today is calculate the sum of the terms of an arithmetic sequence using a formula. Find the sum of a series given two terms of an arithmetic sequence. Determine any term of an arithmetic series given the sum, and one other piece of information you might have to find out first. Alright, so an arithmetic sequence. Here's an example of an arithmetic sequence. 2, 10, 18, 26. So this guy right here, that's a sequence. 2 plus 5, 10 plus 18 plus 26 plus, this is a series. The difference between a sequence and a series. Sequence is a list of numbers. A series is the sum of numbers. Oops. Is a sum of numbers in a sequence. So here we go. Notation, Sn is equal to T1 plus T2 plus T3 plus Tn, where Tn, of course, the last term, and Sn, so these are the same, so T1 is really equal to A, T2 is equal to A plus D, T3 is equal to A plus 2D, dot, 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 plus, and here's our Tn term, as we know that formula from Lesson 1. Alright, Sn, so this is really important. If you ever see the Sn, this is always the sum of terms. Tn is the term number, Sn is the sum of terms. So there's two formulas. There's this formula here, Sn is equal to n times T1 plus Tn, so the first plus the last term divided by 2, and n is the number of terms. The second formula is this, Sn is equal to n over 2, bracket 2a plus n minus 1d. I'm going to show you how to go from formula 1 to formula 2 quickly. This is nothing you need to show, but it's just not even really a proof, but I'm going to show you how to do that. So formula 1, we have this, Sn is equal to n bracket t plus tn all over 2. So the first thing I'm going to do is I'm going to replace this t1 with a, and then I'm also going to replace this tn with our formula from lesson 1, which is a plus n minus 1 d. So if I do that, I get this. I get n bracket a plus n minus 1 d all over 2. And then here I would get n bracket, I can add these two up, a plus a is 2a, plus n minus 1 d, all over 2, but instead of putting it all over 2, I'm just going to put the 2 in front of the n, that's same thing, and here, so this is actually equal to my formula 2. Two formulas, why two formulas? Because there's, formula 1 is a bit easier, but formula 2 is actually more usable. What should be Mr. Real is more usable? When can we, which formula can we use all the time? We can use formula 2 all the time. Why? Because a lot of the time, the restrictions on the first formula is that you need the last term. So if you don't have the last term, you can't use formula 1. You have to use formula 2. So here we'll go from a mild, medium, and then spicy example. Here's my mild example. For the arithmetic sequence 2 plus 5 plus 8, find the sum of the first 10 terms. So here I can see my A is 2. First 10 terms, so here I can see that my n is 10, and then my d will just be the difference between consecutive terms, so 5 minus 2, and that's equal to 3. So I've got all the information. I have a, d, and n. So again, my formula, I'm going to use formula 2. So formula 2, instead of Sn, I'm going to have S10 is equal to 10 over 2, bracket, 2 times 2, plus 10 minus 1 times 3. Here we go, so I'm going to have 5 bracket, 4 plus, 9 times 3. So here I have 5 plus, or sorry, not 5 plus, 5, and that's times 3. So I'm going to have 5 times 4 plus 27 is 31. So therefore, S10, or the sum of the first 10 terms, is 155. So there we go. There is my answer. Done. It's pretty mild. Let's go to a medium question. All right, so find the sum of the arithmetic series, 3 plus 7 plus 11 plus 15 plus dot 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 plus 483. I can actually use formula 1 here. Why? Because I have the last term. I have my T1, I have my Tn. The only thing missing here is, what is my n value? So, to get my n value, I know A is equal to 3, D is equal to 4, so I can plug it in my formula from my lesson 1 formula. Tn is equal to A plus n minus 1 D, plug in my Tn, so 483 is equal to 3 plus n minus 1 times 4. Mr. Wills, while using this formula is going to help us solve for n, because I don't know what my n is, and once I get my n, I can easily solve for that formula, or use this formula. So here we go. Bring the 3 over first, so I get 480 equals n minus 1 times 4. Divide both sides by 4. Get 120 equals n minus 1. So that means n is equal to 121. So there's my formula. There's my n. I have my T1. Oops. I have my T1. And I have my Tn. So here we go. Formula looks like this. So I'm going to have S of 121 is equal to 121 divided by 2, bracket 3 plus 483. Put that in my calculator. This is going to give me 60.5 times 486. And when I put that in my calculator, I get, sorry for the terrible writing, thrilling video right here, Mr. Wills, thank you. 60.5, whoops, times 486 equals 289,403. So S of 121 is equal to that, and that right there is my final answer. So this is the sum of the series. All right. Let's go to the last question, the spicy question. This is this medium spice. Why? Because I needed to figure out what my n value is first. All right, here's the last question. All right, find the number of terms. Ooh, find the number of terms. So that means I need to find n with the following arithmetic sequence. So I have my a value right here, and I can see my d value must be 5. Plus equals this. Ooh, look at this. So here this is, because this is the sum of my terms, this is my Sn. So, which formula am I going to use? Clearly I'm going to use formula 2. Why am I going to use formula 2? Because I don't have my last term, so I'm going to use that one. Alright, so plug in my formula. I have 1,250 is equal to n over 2, bracket, 2 times 15 plus n minus 1 times 5. There we go. Alright, so this is going to give me, let's solve what we can. 30 plus. So I multiply these together, and I'm going to distribute this guy here. So this guy goes here, this guy goes here. So I'm going to have here 5n minus 5. So I get 1,250 equals n over 2, bracket. You're going to get 25 plus 5n. Alright, well, not a big fan of this 2, so I'm going to cross this 2 over here. So I get 2,500 is equal to n times 25 plus 5n. Multiply this n in here. So I get 0 equals, where's 0 coming from, Mr. Wells? Well, I'm going to bring this 2,500 over as well. So I get here 25n plus 5n squared plus, or minus, sorry, 2,500. What do I have here? Well, I have a quadratic formula. Woohoo! As you can tell from the excitement from my voice, we need to solve this. How do I solve this? The quadratic formula. Mr. Wills, come on. So, I've got A, B, and C. So we're going to solve it over here. I'll solve it in green. Why? Why not? So, n is equal to negative b, so negative 25, plus or minus the square root of 25 squared minus 4 times 5 times negative 2,500 all over 2 times 5. So this is going to give me negative 25 plus or minus the square root of all over 10. If I do this in my head, I believe I get 60,000. I'm not going to do it in my head, sorry. Again, thrilling video, Mr. Wells, come on. If you want to fast forward through the next 30 seconds, I'm sure you're going to be fine. 25 squared minus 4 times 5 times negative 2,500. And this gives me 50,000. So that was a bit embarrassing. Let's try this again. So 50,625. There we go. So negative 25 plus or minus the square root of this. By the way, this will always give you a whole number. Why? Because n has to be a whole number. So the square root of this is going to be 225. So I've got two cases here. So case 1, where I'm going to subtract, but if I subtract, I get n is equal to negative 250 over 10, which is negative 25. Or if I add, I'm going to have n is equal to 20. Because n has to be a positive whole number, I reject this, so my answer will be this guy here. So therefore, there are 20 terms in the series. All right, let's look at some homework. So homework, I mean question 4 and 1 are the same, so if you do skip question 1, that's fine. Question 4, question 5 is good. It's asking for Tn and S. And then finally question 6, 7, 15 is a nice thinking question. And 16 is like example 3. Enjoy.